Good day, everybody. This is your professor of this subject, Professor Roger Flores, an associate professor of the Department of Electrical Engineering of the Central Mindanao University, Muswan, Bukidnon. So I will be your professor in the subject EE67, Electrical System Design. And I do believe that this time you are already graduating of your of our course, Bachelor of Science in Electrical Engineering. So this subject will discuss the overall overview of this subject. We will discuss here the Philippine Electrical Code, the Bible of our program, no? So the Philippine Electrical Code. So without discussing this subject, or discussing the Philippine Electrical Code, that is similar to, we don't have religion anyway. So I hope that I will be able to give you some insights. No? If I cannot give you everything in the Philippine Electrical Code, you will be able to discuss, or we will know something related to our field, the do's and don'ts, the law that governed our field of electrical engineering. Okay, so the just to give you in advance that the Philippine Electrical Code that we'll be discussing here is the latest edition, the 2017 latest edition of the Philippine Electrical Code. Okay, so to start with, to begin, so we have to discuss chapter 1, and this chapter 1 is all about the general probation, no? So we will just go over with some important thing in the general provisions of this code. Okay. So this is an introduction. I would like to introduce to you the what is the Philippine Electrical Code? What is the content? What is the authority? What is the what to call this one? What is the the law that govern the installation, the implementation, the do's and don'ts in the designing of electrical installation and wirings. Okay, so we have here what is the purpose of the Philippine Electrical Code. Okay, so we have here purpose first, for practical safeguarding. Okay, so that's very clear, no? It is a practical safeguarding of a persons and property from hazards. No, we have several hazards. Take note that as you might hear that everything that happens, like for example, burning, uh, other accidents related to electrical energy. Okay, so it is always attributed to, okay, failure, short circuit, so on and so forth. So we have this Philippine Electrical Code. Our subject will help us to safeguard against different hazards, no, in the workplaces. Okay, so arising from the use of electricity. Okay, and adequacy also, no, contains provisions that are considered minimum requirements necessary for safety. Okay, minimum requirement. Okay, later on we will know that aside from this Philippine Electrical Code, we have these local provisions for the local legislations of the local government, and the sites where our projects may be located, no? So there might be some provisions of the local government in the construction. So that is why it is considered as minimum requirements only. Okay, so we have this if FPN number 1. So what does this FPN means? So this is uh, fine print notes. These are some of the notes which are very important. No, for number 1, we have hazards often occur because of overloading of wiring systems by methods or usage not in conformity with this code. Okay, so that's very clear that hazards might arise because of overloading of wiring. Now take note that as we know that our wires have its own rated ampacity. So sometimes our load might not or might go beyond with the rating of this conductor. So it might result to overloading and might cause danger to hazards to the people around, no, or the users. Okay, it might not conform with the provisions of this Philippine Electrical Code. So another note or fine print note, which is number 2, it is highly recommended that a licensed electrical practitioner be consulted for any electrical requirements, including changes or innovations or renovations. Okay, so that is very understood for this note number 2, that all the installations in new installations or just a repair or any other renovations, for example, then we need to have an electrical engineer or an electrical practitioner to be consulted or supervise the ongoing installations. Okay. So when we say electrical practitioner, it refers to either professional electrical engineer, a registered electrical engineer, or even registered master electrician. Registered master electrician can manage or supervise installation in the actual installation. Okay. So note number 3, we have this fire hazard, electrocution, serious injury, or even death may also occur with lack or improper maintenance of wiring system. So in other words, as an engineer or an electrical practitioner, our responsibility is not, according to Philippine Electrical Code, it is not until installation. But of course, many years after this work has been done, then our responsibility is still there. No? So whenever there is a problem, maybe caused by hazard, electrocution, injury of the user, then, or the worst is death of the user, then of course it is our responsibility, and we are liable to, because we are the an electrical practitioner maybe who installed, signed, or designed that electrical installations. Okay, so this spec also is intended as a design specification or an instruction manual to a qualified persons. Okay, so of course our designer refers to the scope of authority, scope, and job of the professional electrical engineer. So of course when you are going to design, this Philippine Electrical Code is intended to be our manual, to be our guide, to be for us to be able to specify the design, no, the size, wire size, the specification of any devices that should be or shall be installed in the project. No? Okay. So aside from that, relation to other international standards. Of course, this is Philippine Electrical Code, but at the same time, this is compliant to international standards. Okay, the National Electrical Code or other international standards. Okay, the requirements of this code address the fundamental principles of protection for safety contained in Section 131 of International Electrical Code, no, or the standards. So, for electrical installation of buildings. Okay, so we have this another note. According to Section 131 of this given IEC. So this encompasses protection against thermal effects. Thermal effects, meaning usual hazards, usual event or accidents resulted from uh, high temperature, burning, sparks, or others, no, that will result to burning or fire. Okay, protection against overcurrent, protection against fault currents, and protection against over voltage. Now, so we have the scope of this Philippine Electrical Code. Okay, so we have the first, we have the scope here. Okay. This code covers the installation of electrical conductors. Okay, covers the installation of electrical conductors, equipment, and raceways, signaling, and communication conductors. Okay, so when we say electrical conductors, that is the conductor that will become the path of our current, supply electricity. Okay, when we say equipment and raceways, our equipment being used, our machines, our load, our lighting, for example, and other appliances. And then the raceway also that we're going to use. Maybe we will be using uh, PVC or the polyvinyl chloride, PVC raceways, tubing or tubes, and so on. No. Then we are also it covers also the signaling. If we have some signal sensors and communication systems, no, and other related conductors. Okay, or it does not cover the number one, the installation in railway, rolling stock, aircraft, or automotive vehicles. This code doesn't cover the installation in the LRT, MRT, and other. No, when we say railways, no, the we will not discuss here electrical installations in subways, trains, and so on. No, so and other rolling stock, the movable or transferable residence, for example. Okay, so mobile, moving. So because some of our, for example, some of us using this uh, rolling, no, residence. They are using trucks, no, so that it might transfer one from a place to another places, no, especially if they use this as vacation facilities. Okay, so it does not cover also aircraft or planes or any other flying transportations, no, okay, and other automotive vehicles. So, like for example, installation of wirings, electrical wirings, lamps in the any vehicles. No, it is not included in this electrical code. Okay, so we have here number two. We have installation of railways for generation. So it is not included for generation, transformation, transmission, or distribution of power used. Okay, so railways for this generation, transmission, and transmission or distribution of power used. So we will not discuss it here. It is not the coverage of Philippine Electrical Code. So how about it authority? No, this code has been approved and adopted by the Board of Electrical Engineering and PRC. Actually, people, members, officers, or committee created by the Institute of Integrated Electrical Engineers. So the IIEE created a committee to study this Philippine Electrical Code. And after that study, we have this printout, we have this manuscript, and this was presented to the Board of Electrical Engineering, and that board will approve this one. The approved manuscript will be printed and presented to the Professional Regulation Commission, the implementing institution of the government. Okay, so by virtue of authority vested on the board under the Republic Act 7920, so that is the new electrical engineering law, Republic Act 7920, it hereby directs strict adherence to the provision of this code for the implementations uh, uh, of this electrical code. So, and this law, this Philippine Electrical Code has been given authority by virtue of this Republic Act 7920. Okay. Enforcement. Okay, so how about how it is enforced, no? So this code intended for mandatory application by the Office of Building Official, or the OBO, the Office of the Building Officials, or the building officials, or the electrical engineering over electrical institutions. So the Office of the Building Official will be one of the implementer, or has the authority to implement, to enforce the guidelines and this law, or this code. Okay, so shall have the responsibility of implementing the provision of this code, of course also assessed and guided also by the DPWH. Okay, so this code may require new products, constructions of, or materials that may not yet be able at the time of this code is adopted. Okay, so when we have our new products, new materials, and it was not yet adopted by this law, or this code, but this code, then of course adopted, okay, by the this code also. Okay, mandatory rules, permissive rules, explanatory material, and appendices. When we say mandatory, it means to say that there is the identified actions that are specifically required or prohibited and are characterized by the use of terms shall or shall not. Meaning to say that when we say mandatory, you will be using the word shall. Okay, shall is a word that, according to law, that you should have to abide to. Okay, no exceptions, no options if the word is shall. Okay, it is either prohibited or it is either required. Okay, so next, permissive rules. When we say permissive rules, it is identified actions that are allowed but not required. Okay, so when we say permissive rules, then it is allowed by law. It is allowed by this Philippine Electrical Code through RA 7920, but not required. So there might be some an optional, no, are normally used to describe options or alternative methods. Okay, so we have that permissive. When we say explanatory material, okay, that is the references to other standards, references to related sections of this code. So we have this the International Electrical Code, the standards, international standards. All these things are what we call as explanatory material, considered as additional reference related to this code. Okay, so information related to a code rule in the form of fine print notes. Okay, so we have that fine print notes. About appendices are not part of the enforceable requirements of the Philippine Electrical Code, but are included for information purposes only. Okay, so when it is, if there is a provision that is specified or provided in the appendices, it means to say that it is not part of the enforceable of this code, but it is included for information and references purpose only. So we have this wiring planning. So future expansion and convenience. Then plans and specifications that provide ample space in raceways. Okay, spare raceways and additional spaces allow for future increases in electrical power or electric power and communication circuits. Number of circuits in an enclosures. Okay, so there should be shall be a specific number of circuits and enclosures. It should not be more than what the enclosure specified or provided. No, number of wires and circuits confined in a single enclosure be varyingly restricted according to, for example, the panel board. We have 4 branch circuits. Then of course we will be branch circuits implemented. Maybe we will be up to 4, not more than 4. Okay, otherwise you will be violating some of the provisions of this code. Or let's continue with the definition. Now the definition here will be for some important terminologies only, not all. No, so we have several definitions of Philippine Electrical Code, but what I included here are some of the basic or the common terms that you might encounter always in the implementation of this code. Okay, number one here is, or the first one here is attachment plug or plug cap or just simply plug. No? It is a device by insertion in a receptacle. Okay, establishes a connection between the conductors of the attached flexible cord and the conductors connected permanently to the receptacle. Okay, so that is what we call attachment plug, plug cap, or just simply plug. Okay, so this plug is used to be a device that connects from the extension cord, okay, towards the permanent receptacle or outlet, convenience outlet, for example. Okay, so for example, an appliances. Okay, so we need to have this plug so that you will be able to connect these appliances or supply a load of these appliances from the outlet, no, the convenience outlet or other receptacles. And another term here is authority having jurisdiction or EHJ. So an organization, an office, or individual responsible for approving equipment, materials, and installation for or a procedure. So authority having jurisdiction. So talking about jurisdiction, so it means that it is in our scope or authority or job. It is that is a scope, no? So do not go beyond with our scope or jurisdiction, otherwise we will be liable to law, no? Okay, so bonding conductor, a reliable conductor to ensure the required electrical conductivity between metal parts required to be electrically connected. So bonding conductor, so conductor that connects appliances, for example, and other devices, okay, so that it will be able to, or it will be given power or energy supply. Okay, so next we have branch circuit. So this branch circuit is a circuit conductors between the final overcurrent device protecting the circuit and the outlet. So talking here about the outlet, we have the convenience outlet, and we have the appliance outlet, we have the special outlet or lamp light outlet. So if this branch circuit is a circuit of all this lighting, for example, lamps, then it will be connected to the breaker or the protective or a fuse, a protective device. Okay, so from that protective device towards the lamp, for example, towards the appliance, that is considered as branch circuit. So that is the branch circuit. Okay, circuit breaker, of course, we heard this one already for several times. Circuit breaker is a designed device to open and close a circuit by non-automatic means and to open a circuit automatically on a predetermined overcurrent without damage to itself when properly applied with its rating within its rating. So circuit breaker is used to open and close the circuit, and not automatic. So manual braking, okay, manual shutting off the branch circuit, or it could be automatic based on the predetermined overcurrent capacity of this circuit breaker. So that is called circuit breaker. Okay, so we have also the conduit body. Conduit body is a separate portion by conduit or tubing, which that uh, provides access through removable cover to the interior of the system at the junction of two or more sections of the system or at terminal point of the system. Okay, so the conduit body is the tube, okay, that is used to protect our conductors and other cables. Okay, we have also cut out box. So this is an enclosure designed for surface mounting that has swinging doors or covers. Okay, so that is cut out box. It is not cancelled in the wall or even in other locations. No, it is not cancelled, but rather it is installed in the surface. Okay, so that is a cut out box. Okay, so secure directly to telescoping with the walls of the box proper. So that is the cutout box. Dead front without live parts exposed to a person on the operating side of the equipment. So it is not a live portion of the installation, okay, or the side of the equipment. We have also this demand factor. It is the ratio of the maximum demand of a system or part of the system to the total connected load of a system or part of the system under considerations. Okay, so the ratio of the maximum demand and to the connected actual total connected load. So this means to say that the demand factor is, of course, we cannot say that when we say, for example, in a branch circuit, we have 10 lamps, and maybe we can say that not all 10 lamps will be lighted at the same time. So maybe we will have to reduce something like 80% demand factor, for example, because as I've said, it is a consideration that it is not all, okay, it is not all appliance or loads connected on that branch circuit will be used simultaneously or at the same time. So we have that demand factor. We have the electric sign. So it is a fixed or portable self-contained electrically illuminated utilization equipment with words or symbol designed to convey information or attract attention. So like for example, electric sign, for example, we say fire exit or this way or some other signage, so electrical signage, and it should be illuminated, okay, so that it could be readable to the users or the people using, for example, the sites and locations. No, so we have here also electrical practitioners and or licensed electrical practitioners, okay, who has undergone training in electrical engineering and has complied with the requirements of Republic Act 7920. So I think I mentioned this one a while ago that electrical practitioners refers to the professional electrical engineer, the registered electrical engineer, and the registered master electricians. Okay, we have other practitioners, but of course not registered, but still they are also considered as an electrical practitioner. But what we have here is a licensed electrical practitioners. Okay, so this is the other thing, the non-licensed, who has not complied by the requirements of RA 7920 or a qualified person with relevant education and experience to enable him or her to perceive risks and to avoid hazards. So not compliant with the RA 7920. Maybe because they did not pass the licensure examination, or even they passed the licensure examination but did not apply for a license. So they are still considered as non-licensed electrical practitioners. Okay, by just passing the board examination, either RMA, REA, and for PE, it is not a guarantee that you are already directly licensed practitioner, but still you will be considered as non-licensed if you will not apply in the Professional Regulation Commission. So another word here that we have to define is this ground. Okay, that sometimes some of us might give less attention to grounding system. But of course, this is very dangerous because otherwise, okay, will might damage your installation if it is not grounded properly. So whether intentional or accidental between an electrical circuit or equipment and to earth or to some conducting body that serves in place of the earth. Okay, why earth? Because as we know, the best and efficient grounding is towards ground, which is earth. Okay, or through metals, which will in place by earth also. Okay, so we have here hoist or way. So any shaft way, hatchway, whale hole, or other vertical opening or space in which an elevator or dumb waiter is designed to operate. So what is the difference? Have you heard about dumb waiter? So what is the difference between elevator or dumb waiter? Now, in my understanding, the difference between the elevator and dumb waiter, but still it is used for common transportation in a building, for example, from the lower portion, the ground floor, up to the highest floor of the building. So they are used, elevator and dumb waiter are used for transportation. But the difference there is that elevator is used to transport people, human being, or other small materials or other materials, no? But basically for human being or people. But dumb waiters are those. It is also somewhat like an elevator, but is used only for transporting from the lower to the top part of the building uh, of these materials, okay, supplies, machines, and others, no? So it is not for a human being anyway. So but that is why it is called dumb waiter. Okay, interrupting rating, the highest current and rated voltage that a device is intended to interrupt under standard test conditions. Okay, so that is the rating of your device, protective device. Okay, that is highest, no, highest rating, current and rated voltage to to interrupt or being interrupted from the standard and normal operations. So overcurrent, any current in excess of the rated current of equipment. So for example, the rated current is 30 amperes. Beyond that 30 amperes, then that's branch circuit, for example, will be considered already as we have already that overcurrent. No, so it should be protected, otherwise it will damage our insulation. We have also this raceway, so an enclosed channel of metal or non-metallic materials. So it might be EMT, the electrical metallic tubing, or it might be PVC, the polyvinyl chloride, or maybe some of us will call that one as a plastic material that is used to hold wires, cables, or bus bars, with additional function as permitted in this code also, aside from holding this or as enumerated. Receptacle is a contact device installed at the outlet for the connection of an attachment plug. Okay, a while ago, we talk about attachment plug or plug cap or simply as plug. So to connect this plug to the source, for example, to the outlet, then we have this receptacle. It could be lighting or it could be convenience outlet. Okay, service drop. So we heard this one maybe several times about service drop wires, and so on. This is the overhead service conductors from the last pull or other aerial support to and including the splices, if any connecting to the service entrance, conductors at the building or other structures. Okay, so meaning to say, service drop wire or service drop is a connection conductor connecting from the pole, the primary or the secondary line from the electric pole towards the service entrance. Okay, service entrance that will receive conductor from this from the source. No. Okay, so we have also service point, the point of connection between the facilities of the serving utility and the premises wiring. So when we say serving utility, it refers to the distribution utility. Here in Bukidnon, we have the First Bukidnon Electric Cooperative Incorporated, or that covering southern part of Bukidnon. In the northern part, covered by is covered by the SICAN, or the Bukidnon Sican Electric Cooperative Incorporated, or the BOSICO. Okay, so to discuss about the permits and inspection certificates, we have here the electrical permit needed before work is started. No, so contractors shall obtain electrical permit for buildings or other premises for the from the office of the building of local building officials, or they called some of this they call this one as OBO, the official building official, and the office of the building official, and for watercrafts from the Maritime Industry Authority or Marina. So if you will be installing electrical facilities, okay, so in watercrafts, then you have to apply permit from the Maritime Industry Authority or Marina. What are the requirements for electrical permit? So we have this signature and submittals. So signature of the owner, the designer, supervisor, supervising engineers, and the rest. No, so submit all these documents for with signatures. Okay, and also the applicant. Of course, the applicant may be the owner or the end user, so he will be your applicant, no? And we have also the PEE, or who signed, okay, and sold electrical plans and specifications, meaning the professional electrical engineers who signed and sold the design, okay, or specified the design. Then also another requirement for the permit, we have the licensed electrical practitioner who is in charge of electrical works or installations. Okay, so it could be a registered professional electrical, registered and or professional electrical engineer, or the person who is in charge in the installation, which is the registered master electrician. So see to it that all these personnel, or this practitioner should have this recent license, no, recent license, or recently um, renewed license, no, or holding renewed license. Then building owner, the this will be the building owner and the lot owner, no. So otherwise, the building owner might not be the same person as the lot owner. So we have to ask for the permit of these people and other building officials. No? So it should be submitted, this electrical permit should be submitted in 5 sets of complete electrical plans. Complete. It should not be progressive. Your design might not the building might be progressive, but the design should be submitted complete in 5 sets. No, it should be signed and sealed by the PEE. Okay, so next we have here electrical inspections. So an application for inspection shall be filed with the office of the building official before preliminary and or final inspection is done. Okay, so before the preliminary and or final inspection will be done, there should be or there shall be application for inspection submitted to the office of building officials. Okay. So we have the certificate of inspection. Uh, as we said that what is this certificate of inspection? No electrical installation means alteration or electrical installation, alteration and or addition shall be connected or reconnected to any power supply or any other source of electrical energy without a certificate of final electrical inspection or completion. Okay? So even the distribution utility has no authority to energize, even though they are the source. They will be the one to supply electrical energy, but they are not authorized to energize the electrical installation without approved certificate of inspection. Okay, so talking about drawings sheet sizes, this is anyway standard. So the electrical plans and drawing should be in a 760 millimeter by 1000 millimeter or 760 mm by 1 meter or 0.76 by 1 meter or zero point 0.6 by 0.9. So we have these choices of having this electrical plan. Okay, so the size of the sheets, no? We have this 500 by 760, and then we have, okay, so these are the choices, different sizes of our drawing sheets. So we have graphic scale. So it is said here that since the size of the drawing sheets can be changed photographically, graphic scale shall be shown in its drawing sheets. Okay, so that is very important that you have to indicate the scale of your drawing based on the uh, actual sizes, no? Okay, so we have these plans and specifications. Okay, so location and site plans. So what are the item that is included in the location and site plans? Okay, location of service drop or service drop wire, service equipment, and nearest pool of the utility company furnishing electrical energy. Okay, so you have to indicate, no? You have to indicate the nearest pool where your power supply will be connected to. Then location of the meter as well as the sizes of the service entrance wires, conduits, and equipment. Okay, so location of the electrical uh, electrical meter, no, or electric meter. Then clearance of the path or run of service drops and entrances wires to adjacent existing and or proposed structures. Okay, so clearances, distances between devices and service entrance and any other path, no? So we have to specify that. Then we have electrical layout, floor plan showing location of equipment and the devices and their interconnection wiring. We have plan for power. Okay, you have the electric power. Then you have to plan where we are going to what do you call this one? You have to locate or place, no, or install. Plan for lighting and receptacle outlets. So we have this planning also for lighting and receptacle outlets. You have to design where to place it, and other locations, and we have to specify, Then plan for fire alarm circuit. Okay, so this time the design of the fire alarms and any other protective protective devices for against fire, it is already included in our electrical plan. Okay, so we have also here design analysis, shall be included in the drawings or shall be submitted on separate sheets of standard size and shall show the following: branch circuits of feeders, busways, and service entrances. So we have to include how it is computed, okay, how the current is computed, how to determine the rated protective devices for sizes of the conductor, for branch circuits, for sub feeders and other feeders, the types, ratings, and trip setting of the overload protective devices, either circuit breaker or fuse, electric fuse. Then calculation of short circuit current, that is very important. It should be included in our plan. As we said, it is either integrated in the floor plan and also, or it is in separate sheets. Calculation of voltage drops. Of course, we are going to consider the calculation of the voltage drops. Otherwise, um, it is already low voltage and it will damage your appliances or your load. Okay, protection, coordination over current protective devices. So, coordination, arc flash hazards analysis. Okay, arc flashes may cause burning not only to the structure, to your building, but of course, burning to the users. No? So, we have also the substation plans and specifications. Okay, so we have here for indoor substation, location and dimension, substation structural requirements, because especially this is an indoor. It is within the building. It is very important. And substation electrical requirements and cross-sectional views or drawings indicating all the other installations within the building. Then miscellaneous also. For outdoor, we have shall show some items as indoor substation, except that in lieu of walls and roof, details and fences and fins supporting steel structure shall be shown in accordance with the latest edition of the Philippine Electrical Code, or it is in the Part 2. Okay, meaning to say that in the indoor we have this roofing, we have this walling details, but this time it is of course may apply fences and other supporting steel structures. Requirements for electrical installations. So what are the requirements, basic requirements or minimum requirements for this installation? Discover general requirements for examination and approval installation and use and access to and species about electrical conductors and equipments. They shall only be acceptable if approved. Okay, so this design is acceptable only if it is approved. Of course, who are these people that will approve our design? Of course, the building officials, no, the local governments in charge of the permits and of course permits. No, examination, identification, installation, use, and listing of equipment. So first we have the approval. So the conductors and equipment required or permitted by this code shall be acceptable only if approved. It's very clear. So according to fine print notes 1017, examination of equipment and for safety, for 1.10.1.3, examination, identification of installation and use of equipment. C, the definitions of approved, identification, labeled, and listed. So these are the uh, fine print notes. Okay, we have 1017 and 1013. So for examination, in judging equipment, considerations such as the following shall be evaluated. Okay, suitability for installation and use in conformity with the provisions of this code. Suitability, no, so that's very clear. And then we have here suitability of equipment used may be identified by a description mark on or provided with a product to identify the suitability of the product for a specific purpose. Okay, so we have that FPN. So number 2 for the examination, mechanical strength and durability. So mechanical strength and durability for parts designed to enclose and protect other equipments. The adequacy of the protection thus provided. Okay, wire bending and connection space. That is very important because it might damage our conductor if we just bend it, reconnect it, and without spacing and other considerations. Okay, electrical insulations. Okay, the insulation of the conductor, protection against contacts with the live wires, and so on. Heating effects under normal conditions of use and also under abnormal conditions likely to arise in a service. Normal condition, for example, with this specific thermal value. So how about if it has already a load? So it must have this heating effects. Consider the heating effects. Okay, so what next? We have here arcing effects. Okay, arcing, as we said, this is very dangerous. It might result to burning, not only for property, your building, but of course, burning yourself. Okay, classification by type, size, voltage, current, ampacity, and specific use. Other factors that contribute to the practical safeguarding of persons using or likely to come in contact with the equipment. Okay, let's proceed with installation and use. Listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing and labeling. So talking about listing, product testing. Okay, so you must have to provide product testing, especially if it is a machine, no, a machine. Then evaluation also, the performance, pre-evaluation of the performance, and also the listing product certification. Okay. This listing shall be performed only by recognized qualified electrical testing laboratories. Or like for example, the distribution utilities, they have their own testing materials for transformers and other equipments. So we have these areas. So we have this voltage in which the circuit operates. What is the voltage? Operating voltage. Okay, sorry. Voltage rating shall not be less than the nominal voltage. Okay. So how about conductor? This conductor normally used is copper or aluminum. In the installation, generally we'll be using copper, but there were some conductors used in installation which is aluminum. But generally, most of the time in the installation of the indoor installation, for example, we will be using copper. If not specified, sizes will only to copper, apply only to copper and copper conductors. No? So other sizes may not apply unless it is specified. Okay. So conductor sizes, the sizes are expressed in metric system, or we call this one as SI, the International Standard Metric System. Talking about wiring integrity. So we have this completed wiring shall be free from short circuit and grounds or otherwise stated. Okay. So completed wiring shall be free from short circuits. So testing should be done. Okay. We have wiring methods. Only methods recognized as suitable are included. Okay, see, we have several guidelines on the conducting or implementing wiring installations, but it should be considered, no? Only methods recognized as suitable for are included. The recognized methods shall be permitted to be installed. Okay, interrupting and rating. I think we mentioned this one a while ago. Shall have a rating sufficient from the nominal circuit voltage at least equal to the line current terminals. Okay, so listed and labeled with not required. Listing and labeling of conduct products shall not be required if local or international standards do not require. If it is not a requirement for local and national standards, then never mind doing this listing and labeling. So, mechanical execution of works. Electrical equipment shall be installed in a neat and workman-like manner. So, installation should be done in as neat as necessary, no? Unused opening shall be closed to afford protection. Okay, so used opening shall be closed to afford protection. If there will be some opening, for example, doors, or we have this manhole, or we have these boxes, we have the utility box, outlets, then of course we have to use closed protection, no? So we have integrity of internal parts shall not be damaged or contaminated with foreign materials. Okay, so mounting and cooling of equipment. Equipment shall be firmly secured to the surface. Wooden flags driven into holes in masonry and concrete plaster or similar materials shall not be required. So they are not required. Equipment of natural circulation and air and convection principles for cooling shall not be prevented by wall or adjacent equipment. So electrical connections. So conductor of dissimilar materials shall not be intermixed in a splicing connector where physical contact occurs between the dissimilar conductors. So, right, for example, some events happen that there is a short circuit because of conductor copper connection, and maybe there is a reaction, okay, chemical reaction. Then there was, or there is now what we call as loose connection, and it will cause to hazard. Okay, so what else? Yeah, shall be more stranded than class B and C. An installation where a tightening torque is indicated as numeric value on equipment or an installation. Okay, so we have this high leg marking. Only the conductor with higher phase voltage to phase voltage to ground shall be marked with orange color. So in other words, upon testing, we cannot immediately tell that this is the color, no, or this is the markings. So we have to test that one. Okay, so you have to ask approval to the engineers and end users. Identification be at the connection. Okay, so arc flash hazard warning. So general electrical equipment or require examination, adjustment, serving, or maintenance while energized. Okay, service equipment other than at permanent label shall be filled or factory applied to service equipment rated to 1,200 amperes or more. Okay, so identification of disconnecting wires. General, its disconnecting means be legibly marked indicating its purpose. Okay, engineered series combination systems. Okay, enclosure for circuit breakers in compliance with series combination ratings. Okay, then shall be eligible or eligible mark. Current transformers. Okay, So unused current transformers associated with the potentially energized circuit shall be short-circuited. So that's very clear. Available fault currents. Okay. Failed markings. Maximum failed current. Marking shall include the date of the fault current calculation was performed at the same time modification. So this modification, if conducts modification was made, the maximum available fault current shall be verified and declared recalculated as necessary. Okay. So equipment provisions. So termination provision rated 100 ampere or less or marked for 20.0 millimeter squared 1.6. Okay. 38 millimeter squared conductor shall be used only of the following. Conductors rated 60 degrees Celsius. Then the conductors with higher temperature ratings based on 60 degrees Celsius. Conductors with higher temperature ratings, if listed for use with such. Okay. For motors with design letters B, C, or D stamped in the nameplate of the motor, with insulation of for 75 degrees current degrees Celsius or higher shall be permitted if ampacity does not exceed or 75 degrees Celsius. Okay. So next we have this termination provision rated 100 to or less or marked for conductors larger than 38 millimeter squared shall be used only for not one of the following. So we have this conductor rated 75 degrees Celsius. We have conductors with higher temperature does not include to 75 degrees Celsius opacity or up to opacity listed and identified for use with such colors. Separate connectors. Okay, separate connectors here. Or separately installed pressure connectors shall be used with conductors of the ampacity not exceeding the ampacity of the listed and identified temperature rating of the connector. Okay, so this is all about the conductor ampacities, no? Conductor ampacities. Okay, we have next the workspaces, no? This is in millimeter. So nominal voltage to ground. When we say, for example, 220 volts, so that is in between this is in between 601 or that is 220, that is 151 degrees 151 volts to 600. We have this 9 1000 1200. So that is the workspaces specified conditions. Okay, so we have condition 1, expose live parts on one side and no live or grounded parts on the other side, or exposed live parts in both sides are guarded by insulating materials. Okay, so we have condition 2, exposed live parts on one side and no live or grounded parts of the other side, concreting brick or tile, which shall be considered as grounded. Okay, so we have additional grounding system. Okay, condition number 3, exposed live parts on both sides. No? Exposure of the live parts of both sides. We have enclosed equipment accessible to qualified persons. So, who are these? No? Opening shall be designed to deflect foreign objects foreign object inserted. So nuts and bolts exposed are not readily removed pertaining to access to live parts. Okay. So lock chrome enclosures. So at over 1000 volts shall be kept locked unless other observation of the licensed electrical engineer or qualified person in under the supervision of a licensed electrical engineer. So those are some violations if we can follow these circuits. Okay, so next we have if 1000 volts or provided, permanent and conspicuous warning signs shall be provided with as follows. Control by automatic means shall not be permitted. Lighting outlets shall be arranged so the person changing lamps or repairing are not endangered by live parts of other equipments. And then other one here. Okay, so that is elevation of unguarded live parts, no? So we have that. And then by the way, before we will continue, so we have this nominal voltage to ground, condition number 1, that is the distance, condition number 2, and condition number 3 as specified a while ago. So, okay, of course, we have here, no? It is just refreshed here. Okay, these are the different conditions. Protection of service equipment, switchgears, and industrial control assemblies. So, pipes or ducts or foreign to the electrical installation whose malfunction will be endangered. The electrical system shall not be located in the vicinity of the equipment. Okay, so piping and other facilities are not considered foreign if provided for fire protection of the electrical installations. So we have these circuit conductors are permitted, no? We are permitted to be installed in raceways, cable trays as metal clad cable. So we have that metal cladding, bare wire, cable, and bus bars, but shall conform to standards. Insulators used in mounting and must withstand the maximum magnetic forces of a circuit subjected to short circuit current. Support for lead covered cables shall be designed to prevent electrolysis of the effect, no, of the sheath or of the conductor cables. Inspection and tests. So pre-energization and operating test. So before final operations. So we have to pre-energize and test, no. So the complete electrical system design shall be prepared in advance and made available on request of the office of the building officials and the electrical engineers. So we have this one. So like for example, if we have this distances, no? If the voltage is between 1001 to 7500, the elevation of the conductor, the overhead conductor or overhead elevation is 2.05 meters. Okay, so that is the maximum. So if it is 7501 to 35 kV voltage, then the distance or the overhead distance shall be 4.57 meters. Or if it is over 35 kV, okay, so we have that add 9.5 millimeter per kV above 35 kV. So for example, if our transmission lines or our conductor carries for example or 69 kV, then it must have 9.5 millimeter increase of the distance per kV. So per kV above 35. So that's it, no? How to compute for the elevation of the conductor overhead, no? Elevation. Test report shall be available at OBO, okay, or EE prior to energization and made available to those authorized to install, operate, test, and maintain the system. Okay, we might have tunnel installations. Okay, so if we have these tunnel installations, then we have this consideration. This shall apply to installation and use of high voltage power distribution and utilization. Okay, so equipment that is portable, mobile, or both. It is either portable or mobile equipment. Conductors and cables in tunnels shall be located above the tunnel floor. So, installation at the tunnel, conductor should not be placed at the floor, but of course, it should be placed above the floor, or it is either overhead in the tunnel. Okay, so manholes intended for personnel entry. So it is required here or specified that if we have manholes, then enclosure intended for personal entry shall be of sufficient size to provide safe work and shall be designed to withstand all loads likely to be imposed on the structure, with a workspace of not less than 900 mm wide if cables are on both sides, or 750 mm if only on one side, not less than 1800 millimeter. Okay, high unless opening is within 300 mm. Okay, opening shall not less than 650 by 550 millimeter round. Axis not less than 650 by 650 millimeter in diameter if it is rounded. Okay, so that is your manhole. Now, why is that we are going to specify this diameter or opening? Because, of course, it is very clear that for the worker, for the electrician, for the installer to work it efficient distances, no, or safe work. Then cover shall be over 45 kilograms labeled. Okay, so for example, if the cover of the manhole is over 45 kilograms, then it should be labeled. Okay, so those are the things included in our chapter 1, the general provisions. But of course, as I've said in the starting line, that this is not complete. So we should have, meaning we should have to read more. Okay, there were some which is not so discussed well, or it is not provided because maybe it is not as significant with these things that we discuss. So I will advise you that continue reading for this chapter 1, which is the general provisions. Of course, later on it will be uh, uh, fully specified, provided according to the law, the RS 2920, and of course the Philippine Electrical Code 2017 provisions. Thank you very much. Thank you for listening.